Hello everyone, welcome to 11th hour. So in this video, we are going to look at conversion from the decimal number system to any radix as in base. So let's get started. So let's look at an example where I want to convert a decimal number into an octal number, for example. So in this case, I want to convert, say, 246 maybe base 10 to radix 8. So octal. When the radix is 8, the number system is said to be an octal number system, right? So I want to convert this decimal number into a radix 8 or an octal number. So to do that, I need to divide this decimal number by 8 for the integer part. So if I have a decimal part to it, what do I do? Let's look at it step by step. So I want to convert 246. So I have to divide it repeatedly. So 8, when I divide it by 8, I get 8 threes are 24 and 6 is the remainder over here. Again, 8 threes are 24, 6 is the remainder. Now 3 is lesser than 8. So we need to stop our division here and write the number in this manner. So our result is going to be 366 in the radix 8 number system. Suppose I have some decimal part to it. Say I have 246.01 base 10 and I want to convert this into radix 8. So the integer part has to be dealt in this manner. For the decimal portion, what I have to do is I need to multiply this with 8 repeatedly till I get recurrent numbers. So when I multiply this, what do I get? I get 0.08. I'll retain the integer part over here and carry forward the product that I've got, the decimal part of it rather, 0.08 into 8. So what do I get? I get 0.64. I carry this forward, 0.64 into 8, 5.12. Then I carry 0.12 forward. I'll retain 5. 0.12 is carried forward and I get 0.96. 0.96 is again multiplied with 8 and so on, right? So I have to continue this till I get repeated numbers. So now, how do I write the decimal part of it? I have to look at it top down. So what I get here would precisely be 0, so 0.0050 and so on, whatever comes after this, right? So I have to write 366.0050 etc base 8. So this is how we deal with the decimal portion of my number, base 10 number. So if it is the integer part, I have to repeatedly divide it by the radix to which I want to convert. If it is the decimal portion or the fractional part, I have to multiply it repeatedly with the radix to which I want to convert it to. Let us now look at the example where I want to convert a number from, say, base 8 to decimal. So how do I do that? So let's say my base 8 or radix 8 number is 366.01 and I want to convert it to radix 10. So here we are going to apply the position of each of these digits. So the position of this 6 is 0, this is 1, this is 2, and on the other side of the decimal point, this is -1 and -2. Now, in order to convert the integer part, I have to multiply each of these digits with 8 to the power of the position. And for the numbers on the other side of the decimal point, that is the fractional part also, we are going to multiply each of these fractional parts with 8 to the power of that particular position. So that is in case we are going to convert it from base 8 to decimal. So let's go on. So this would be 1 into 8 to the power minus 2. This is 0 into 8 to the power minus 1. This is 6 into 8 to the power of 0. Again, 6 into 8 to the power 1. And this one is 3 into 8 to the power 2. So this essentially is 0. This turns out to be 0.015. This is 6. This is 48. And this is 192. Now we have to add up all this and we'll get our decimal number. So the integer part turns out to be 246 and the fractional part is 0.015. So we get 246.015 to the base 10. So this is how we convert base 8 number to a decimal number. Now say there is, so base 8 is octal system, it is very famous, but say we have some arbitrary radix, say base 4, then what do we do? Right? So if I want to convert from decimal to base 4 and base 4 to decimal, even then we need to apply the same steps. So if I want to convert this decimal number into a base 4 or a radix 4 number, I have to divide this integer part by 4. The remainder is 2. The remainder is 1. The remainder here is 3. Write the number bottom up. So here we get 3312 base 4. So this is the integer part of my base 10 number. So 246, when I convert it to a base 4 number system, I'll get 3312. So if you observe, all the numbers are within the range of 0 to 3 because in the base 4 number system, I can have only 4 symbols 0, 1, 2, and 3. So this is valid. In case once you convert, you see that the numbers after the conversion don't lie within the range, you can be assured that there's something wrong in your conversion. For the fractional part, again, we need to multiply each of these digits with 4, retain the integer part to be written in the result, and carry forward the fractional part, just as how we did it in the previous example for radix 8. Now, if I want to convert a radix 4 number into decimal, I have to apply the same principle, just that in this case, I'm going to have 3312. The position here is 0, 1, 2, and 3. And I want to convert this to base 10. So I should get 246. So with each of these digits, I have to multiply 4 to the power the particular position. So 4 power 0, this is 4 power 1, 4 power 2, and the last one is 4 power 3. So on doing this and adding it all up, I would get 246. So this is the conversion from base 10 to any radix and any radix to base 10. That's all with today's video. I hope the conversion, the decimal number based conversion is clear to you all. If you have any queries, please don't hesitate to post it in the comments. Do subscribe to this channel for more such videos. Thanks for watching.